Hello, hello guys. Is my voice is audible?
Yes, Vishnu, it's audible.
Yes, yes.
Yeah, thank you for the response. And I welcome everyone to the project week and day two. And this is a final day. And guys, and yesterday we have done with presentation like day one, and it's gone really well. So now it's time for day two, and I hope you guys are ready with your projects.
Yes.
Yeah,
Yes.
okay. So first person to present is Worship. Worship, are you ready?
Yeah.
Yeah,
I will present my screen.
yeah, Worship. Yeah, Worship. Go ahead.
Is my screen is good? Hello.
Yeah, it's visible, Worship.
Yeah, okay. So, today for our Phoenix Robotics Club project week, um, I did a project of water tank management. I am Varshit from ISC department. So first in this project, like there will be a whole system of project which in the tank so that the the ultrasonic sensor can sense the distance and according to that the water will flow so that the motor will run the water in this. As I said, that ultrasonic sensor will release and emit waves so that according to it it will tell the distance to the Arduino so that Arduino can send the sensors to the motor, and according to that the height of the level of the water it will uh, release the water. In this the main thing is Arduino. As all we know that Arduino is a open source and a microchip at Maga 328, and with the use of Arduino we can do many projects. Only a single board we can connect many things. And second important thing is ultrasonic sensor. By using this sensor only we can know the distance of the means at what level the water is there. And for releasing the water we need motor and buzzer for just for knowing, and breadboard for just connecting all the circuits, and motor driver so that motor will need more amount of current so that motor driver will help. And this is the diagram how the whole the connections will be. Now I will show the stimulation. Yeah, it will be like this. First I will start simulation. Yeah, now according to the distance the motor will start running. Like you, you can see here. One, yeah. According to the height of the water, the motor will start running. Like you can see, if the level of water is more, then the motor will start running. If the level of the water is less, Then you can see like the motor stops running for some time. Like this it will be like, now the code is like just for reading the amount of the water and whole thing. So as shown in this circuit diagram, the same the thing will be like. So from this we can tell like, by using this, we can easily control the water without our daily. So that's it. This is my project. Thank you.
Yeah, nice presentation, Worship. Next is Pallavi KG. Pallavi, are you ready?
Yeah, I'm ready.
Yeah, go ahead.
Is my screen visible?
Yeah, Pallavi, it's visible.
I'm Pallavi KJ from CSE department, and I'll be talking about oscilloscope. Oscilloscope is an electronic instrument which is used to graphically represent voltage changes over time, and it can be adjusted so that the repetitive signals can be observed as a persistent waveform on the screen. And here we are implementing oscilloscope using a microcontroller, Arduino Uno, a function generator, and a LCD. And these components are connected using jumper wires, and the corresponding wave is represented on the LCD. Working principle. A liquid crystal display is used to display the wave based on the input given through the function generator. And this input, which is given to the function generator, is the parameters of the waveform, such as the amplitude, frequency, and DC offset. And we can also specify the type of the waveform, that is triangular, sine, or square waveform. And the wave corresponding to these set of parameters is displayed on the LCD using Arduino Uno. These are the equipments used. Arduino Uno, it is a microcontroller which has 14 digital and 6 analog input-output pins, and 16 by 2 LCD. LCD stands for liquid crystal display. It is an electronic display module, and the benefits of using LCD here is that it is inexpensive and it is easily programmable. And function generator, it is a form of instrument which can generate waveforms with common shapes such as sine, square, and triangular. And we are using resistors and we are using connecting wires to connect these components. This is the circuit diagram. Here is the microcontroller, the function generator, and the LCD. I'll be showing the simulation. Here, the triangular wave is chosen with 3 kilohertz as frequency and 7 volts as voltage and 5 volt as DC offset. Now it is sine wave. DC offset is the distance between the waveform, that is. And now we can see that the distance is increased on increasing the DC offset. And this is the square waveform. As we've seen that oscilloscope is a powerful tool which represents how voltage changes over time. And oscilloscope with storage features allows signal to be captured, retrieved, and analyzed for later use. And it has many applications. It is used in electrocardiograms to test circuits and to troubleshoot electronic devices such as televisions. Thank you.
Yeah, nice presentation, Pallavi. So next is Aditi. Yes,
Yeah,
are you ready, Aditi?
yeah. One
Yeah.
second. Can you see my screen?
Yeah, yeah, Aditi, I can see it.
Good evening, everyone. I'm Aditi from CSE. My project topic is digital clock. Digital clock, as we all know, is a type of clock that does not have pointers or hands to indicate hours and minutes, as in analog clocks, and it displays them digitally. Digital clocks are generally smaller and easy to use than analog clocks. The first pocket watch that was considered digital was introduced in 1883, and it used the jump hour mechanism. This was created by Joseph Paul Weber. The jump hour featured two windows through which you can see the hours and minutes on rotating discs. Next came Plato clocks, which has had similar idea but used different layout structure. And the first digital alarm clock was patented in the year 1956. Digital clocks typically run off an electric power supply, such as 100 to 200 volt AC power cord to the wall. However, most digital clocks have battery backup in case of a power outage. The display on the digital clock either consists of LEDs or LCDs. Coming to the components required, the first is the Arduino Uno, which is the microcontroller. Then resistors. In this project, two resistors are required. Connecting wires, push buttons, two push buttons. I'll explain in detail what they are for in the coming slides, but basically they are used to alter the time displayed. And the last is the LCD display, in which the output is displayed. The basic operation of the circuit is to display time to the user. Um, Here, once we click on simulation, the time is displayed in LCD, and it is displayed in the form of hours, minutes, seconds, and AM or PM. If we want to alter the time displayed, it can be done so with the help of two push buttons. One is for the hours and the other is for the minute displayed. If we double click any of the push button, then hours or the minutes increases by one, and long pressing it it increases the time displayed continuously by a factor of one. This is the circuit diagram. Arduino Uno, LCD, resistors, and the push buttons. I'll do the simulation now. If I click on start simulation, the time is displayed here, and it starts from 12 because in the code it is initialized to start from 12. And these are the push buttons. Double clicking one of them increases the minutes, and the other one increases the hours displayed. So if we long press the push button, then it increases continuously. The same is with respect to the hours. And if the value exceeds by 12, then it will be displayed as PM, as it is displayed here. So this can be used to set a particular time that we want, and this is done with the help of push buttons. So this is it about the simulation. Clock is one of the oldest human inventions and forms a very important part of all our lives. Digital clocks are small and inexpensive and can be used everywhere. Our homes, they can be wristwatches or they can be used in cars, radios, television, and so on. And these definitely help to make our lives easier. In this project, Arduino microcontroller is used. There can be other other microcontrollers that can be used, and the circuit can definitely be improved to include other features and make it better. So this is it about my presentation. Thank you.
Yeah, really nice presentation, Aditi. Yeah. Next is Rahul M. Bharadwaj. Rahul?
Yes, Vishnu, I'm ready. Can I present?
Yeah. Yeah, you can present. Go ahead.
Thank you. Can you see my screen?
Yes, Rahul.
Okay, thank you. A very pleasant evening to all the viewers. I am Rahul M. Bharadwaj, a first year CSE student from RVITM. So today I'll be explaining in detail about a project that has the potential to prevent a major traffic violation and consequent deaths if implemented on a large scale with necessary modification and enhancements to suit the requirements of a particular region. And here's the project: the Automatic Traffic Signal Jump Prevention System. India unfortunately finds itself in the infamous list of top 5 countries recording the highest number of deaths due to road accidents annually. And the obvious reason is the reckless driving by the motorists, apart from other factors like potholes and other infrastructure loopholes. And on an average, in our country, 30.1 million vehicles register to ply on our roads annually. And with this, the road networks are increasing at a very rapid rate, and proportionally, the number of traffic violations and the deaths caused by these violations are increasing at an alarming rate. On the slide, you can see that the number of deaths due to traffic violations in our country annually stands at 151,000. So that's a very huge economic loss for the country in terms of human resource. So keeping all these factors in mind, we have come up with a project that has the potential to reduce and prevent traffic signal jumps, which is one of the major most traffic violations in our country, and also the deaths caused by this major traffic violation. And here are the materials used for this project. I mean the prototype. We have used an Arduino Uno and 5 LEDs, out of which 2 are red LEDs, one's yellow, and 2 are green. And we have 2 micro servos and a piezo buzzer and 5 220 kilo ohm resistors. Moving on to the working principle, this entire project revolves around the mechanism of lifting up and lowering down of nails that are attached to an iron bar and operates synchronously with the traffic lights. I'll be explaining this in detail along with the simulation. As previously mentioned, this project makes use of 5 LEDs. In this prototype, we make use of 5 LEDs, out of which 3 lights will act as conventional traffic signal lights, and 2 are warning lights. One is the red and the other is the green. So these warning lights will be placed at appropriate distances and appropriate heights and in appropriate numbers to meet the requirements of a particular traffic junction. Now we can understand this better with the help of the simulation. So here's the circuit of the project. As I previously mentioned, you can see 3 LEDs on the top. They are the traffic signal lights in this prototype. And then we can see 2 more LEDs, one red LED and a green LED. And there's a piezo buzzer attached in series with the red LED. So how this project basically works is, when the traffic signal light turns red, the servo motors at the bottom, which you can see in the circuit diagram, will move up by an angle of 90 degrees, thus pushing up the iron bar and the nails, which are specially designed above the road level such that the nails are pointing up. So at this point, if any vehicle tries to cross the traffic signal, obviously the tires will get punctured. And when the traffic signal light turns yellow, a green warning light placed on the dividers at an appropriate height will go on, telling the users that the iron bar mechanism or the iron bar fitted with the nails will go down in a while to make way for the traffic to move forward when the traffic signal light turns green. And as mentioned, when the traffic signal light turns green, the servo motors will revert by an angle of 90 degrees, thus pulling the iron bar and the nails attached to it back and making the road flat so that the vehicles can easily move. And again, after this green light goes off and shifts to the yellow light to move further to the red traffic signal light, there will be a warning light, the red warning light, and the piezo buzzer will go on simultaneously, warning the users to slow and stop so that they do not pass over the nails, which will come up and get the tires punctured. So this will be the warning lights. And as soon as the signal light turns red, the servo motor will move up again by 90 degrees and push the nails above the road level. Now we can see the simulation here. As you can see, as soon as the traffic signal light turns red, the servo motors will move up by an angle of 90 degrees. And this will stay there as long as the traffic signal light is red. Now, this light shifts to yellow and you can see a green light blinking. That is the warning light. And the servo motors will stay in that position. And as soon as the traffic signal light turns green, the servo motors will go down and pull down the iron bar, making way for the vehicles to move forward. And this continues. And you can see that there's a warning light and the buzzer going on as soon as the signal turns yellow again, indicating that the user should slow down and stop. And when it comes back to red, the servo motors will move up again. So this is all about the simulation. Moving back to the presentation. Here in this slide, we have a summary of the entire working mechanism of the project. And most importantly, the iron bar and the servo motor arrangement will be placed in channel-like boxes in accordance with the width of the roads. And the lid of these boxes will play a major role here. Whenever the nails move up above the road level, they'll move aside, making way for the nails. And as soon as this servo motor reverts, the lid will close over these boxes, and this is done to prevent any mechanical damages to the nails and the iron rods. And as in any projects, there will be challenges and need for improvements. And in our project, we all are aware that emergency vehicles are very important and we have to make way for them during traffic jams. And that's a very important thing. And unfortunately, it's not followed properly everywhere. So for this problem, we propose a solution by making dedicated lanes for these emergency vehicles. And these lanes will obviously be misused by normal vehicles. And we also have a mechanism to prevent that. A special RGB color-coded sensor module, which can sense a particular range of frequencies. That's a small range of frequencies. It will be pre-coded and placed at the entrance of these special lanes according to the length of the traffic signal. And these will be present at the entrance as mentioned. And each and every emergency vehicle in the city will be provided with a unique RGB color-coded badge. And these badges will not be available to the common public. And this will be given only to the emergency vehicles and the managing organizations by the government or any other organization taking the responsibility. So as soon as the emergency vehicles approach these emergency lanes, they can just point the badge at these pre-coded color sensor modules. And when the frequencies match, the iron bar at the end of this dedicated lane will move down and make way for the emergency vehicle to easily cross the traffic signal. And this lane cannot be misused by normal vehicles because the motorist will not have access to these special color-coded badges. So this will also prevent the misuse of these lanes and will serve the actual purpose. Now you can see the top view of the traffic signal, how it will look. So here you can see the conventional traffic signal lights and a dedicated lane and warning lights placed on the dividers and RGB color sensor module at the entrance of the dedicated lane. And this is the overall top view of the project, how it will look, a basic traffic signal. And here we saw the circuit diagram in the simulation as well. And moving on to the conclusion, this idea, as I previously mentioned, if implemented on a large scale with necessary modifications, can prevent millions of deaths across the world caused by these traffic rules violations. And as we all know, each and every second is important for a patient who is in an ambulance and who's in a dire need to reach hospital to get cured. And also it's the same with other emergency vehicles like the fire engines, because each and every second will matter a lot to save thousands of lives. So if we are successful in preventing the delays caused by these traffic jams, we can save thousands of lives across the world annually. So as responsible citizens and as part of the RVITM family with an aim to make our roads safer, we hope that this small attempt by the Phoenix Robotics Club can be of some use to the society in future. Thank you very much.
Yeah, it's really nice presentation, Rahul, and somewhat tried innovative and like explaining it for a better way. And hope we can
Thank you,
implement it
Vishnu.
practical. Okay.
Thank you, Vishnu.
And yeah, next is Abhyuday.
Hello, am I audible?
Yeah, it's audible, Abhyuday.
Yeah, just So basically, my project is a smoke detector. A smoke detector is an electronic fire protection device that automatically senses the presence of smoke as a key indicator of fire and sounds a warning. This is quite helpful and can prevent a lot of deaths. So the working principle is we use a gas sensor. When smoke is generated, the output voltage of the gas sensor changes. As a result, the presence of smoke in the surroundings can be sensed, and then a buzzer is sounded so that the residents can know that there is a fire. Equipments used are Arduino Uno, gas sensor, buzzer, a breadboard, resistors, and connecting wires. This is the circuit diagram. I'll just show you the simulation. Yeah, so this is the simulation. Right now you cannot hear anything because there is no smoke. When there is smoke near the sensor, it starts ringing. Yeah, that's all. And then and the conclusion is this is a very cheap and easy to use device and can prevent a lot of deaths because as per survey mostly deaths happen because by the time the residents realize that there is a fire it is too late. That's all. Thank you.
Yeah, thank you, Abhiday. Nice presentation.
Thanks.
And next is Kushal Goyal. Hello, Kushal.
Yes, yes, I'm presenting.
Yeah,
Can I start?
yeah, you
Can
can,
I
Kushal.
start?
Go ahead.
Okay, okay. Good evening to one and all present here. Today, I will be going to speak on my topic, motion sensor RC robot. So, talking about what is the project? So, this project is used to run a robot backward, forward, left, and right by using sensor or by taking the input from the user. And if the robot is moving backwards, it creates a buzzing sound with the help of a buzzer. So, how this project works? It works on the principle of the PIR sensor. If it detects motion, then it will return its value as 1. And it has three sensors, one for the front, one for the left, and one for the right. And if it detects motion at the front, then it will go backwards and it will create a noise with the help of buzzer. And if it detects motion in the left, it will go in right direction. And if it detects motion in the right direction, it will go in the right, it will go in left. Apart from this, it can also be controlled by the user. So if the user enters F, it will go in forward direction, and if the user enters back B, it will go in backward direction. And by going in the backward direction, it will make noise with the help of a buzzer. And if the user enters L, it will go in left, and if the user enters R, it will go in right. So talking about the equipments which are used for making this robot, Arduino Uno, which is a microcontroller board which has 14 filters 14 digital input output pins and 6 analog pins. PIR sensor, which is used for the motion detection, and piezo buzzer. This is a tiny speaker which is directly connected to the Arduino board. L293DH bridge motor driver is an electronic circuit which can supply current in both the direction. The DC motor is a normal motor, and it has two pins, positive and negative. The jumper wires are the simple wire which are used to connect 2 points and which has connector pins at the end. So this is how the robot looks like. This is the PIR sensor. This is the DC motor. This is the L293D H bridge motor driver. This is the Arduino Uno board, and this is the piezo buzzer. So now I'll show how the robot works. So first of all, I'll start simulation. By default, the robot is moving in the front direction. If I enter L, then the robot is moving the left turn and it will go again in the right. If I'm constantly pressing L, then it will go in the left. I put R, then it will go in right. And if I press B, it will go in back and it will create a noise using this buzzer. So now, talking about the sensor. So if it detects motion in this left sensor, then it will go in right. And as you can see in serial monitor, it's showing robot is taking the right turn. And if it detects motion in the right sensor, then it will go in left direction. It will take left turn, and in the serial monitor, it is showing. You can see it is showing the robot is taking the left turn, and you can see the motion, the motor RPM also. Like for this RPM, it is moving the left. So now, if it detects motion in the front direction, then you can see it will go in backward direction, and you can also see like the buzzer is also making a noise. So it can alert the nearby vehicles or nearby people, like the robot is taking the that one. So now talking about the conclusion. This project can be used to make the motion sensor robot, and apart from this, the Arduino can be used for various range of purpose like games, robot devices which are used in everyday life. So everyone must know the basics about Arduino. Thank you.
Yeah, really nice presentation, Kushal.
Thank you.
Okay, 1 minute. Okay. So now I think everybody is completed. I think now we come to the like ending of this project week and day two, and we have conducted day one and day two this project week, and we planned for a long time, but unfortunately, and due to difficult schedule, due to like messy schedule, so we planned only for 2 days. So guys, how do you feel this session?